All right, here's a tap that I had scheduled, but I burnt that time for this one, talking through the examples. I think in the future I'll do more screencasts, and I really want you to post questions to the discussion forum, and we'll have a discussion about that. I can do some real-time online chats, or of course my office hours and in person are also available. So I started with the chapter 2 tap 2 graph that you probably just looked at. And now what's happening, the shuttle of the loom that she used to weave placemats has worn out. So she can't afford to repair the machine, so now she's down to only making 4 placemats per hour, but she can still make bracelets at the same rate as before. So she's working 40 hours, she can now only make 4 per hour, so the most placemats that she can make, if she puts all her time in placemats, has fallen to 4 times 40 or 160. Nothing's changed on the bracelet side, but the trade-off is still constant. So we draw that new PPC. We'll call it very creatively PPC2. Anyway, it's shifted in. You have a problem in your homework where it shifts out because of increased productivity, but I thought I'd give you the opposite case. So that's how you do it, the graph, but most of you are pretty comfortable with the graph. I think now I've done it freehand, so the graphical method that I toyed with last time isn't going to work. So now we have these points to check. 200 bracelets, 100 placemats. It actually looks sort of ballpark correct given how crude my graph is, but let's think it through. If she's making 200 bracelets, that means she's got 20 hours in bracelets. So she's got 20 hours available for placemats. Her maximum placemats then would be 20 times 4 or 80. So I guess my crude drawing is actually leading us. So this point, 20 and 100 would be up here somewhere. Sorry, 200 and 100. I'm going to even write that 200, comma 100. You always do x first and then y coordinate, horizontal axis coordinate, comma vertical axis coordinate. So that's going to be unobtainable or unattainable. And we're just not going to even comment on efficiency there. All right, 150, 100. 150, 100. Oh boy, now that's looking pretty good, but we better go through it carefully. She's got 15 hours in bracelets. 15 times 10 is 150. And that leaves her 25 hours to make placemats. And lo and behold, 25 times 4 is 100. So this is 150, comma 100. And now it is attainable, and it's now relevant to call it efficient as well. It's right on the line. And then finally, I've made a mess of things, but 100 and 120, let's just think that through. I'm going to just do this up here so I have some room. 100, comma 120. And she's got 10 hours in 10 hours in bracelets, and she's got 30 hours to put over in placemats. And my crude line looks like it's on the line. Let's think it through. She's got 30 hours times 4. 30 times 4 is 120. So this also is attainable and efficient. I was trying to penalize the person that was just taking a shortcut, or the team, and saying, oh, wow, he's got unattainable, attainable, and this one must be attainable but inefficient. But I would have caught you if that was you, but you guys are all too smart for that. And then as far as this last part, this is new. What is meant by the following statement? Decrease in productivity with respect to any one good decreases our option for producing and consuming all other goods. So we see that the whole curve has shifted in, even though it's only placemat productivity that's changed. Only this point where we're not producing any placemats is unaffected. And that's simply because now it takes more resources to make any quantity of placemats, and that leaves fewer resources to make bracelets. So even though bracelet productivity was unaffected, our drop in placemat productivity affected our ability to make bracelets.
Made with Doodlecast Pro.